Hello friends, welcome to Joy of Life. So this is the third episode of System Design Fundamental, and before we start, we are going to take a look at the questions that we have got and we are going to address them first. KSCCH has given a comment, thanks for the video, can you use a black background? So thanks KSC for your comment, and we are going to change the background. It does make sense, the background and the text color is not good, so let me go ahead and change the color to black as suggested by you. I hope it is good now, better now. Aditi has said another great video. So thanks Aditi. Your comment means a lot to me. Do let me know if you have any doubts or if you want anything else to be explained by me apart from what we are discussing. John Wick says, thanks for the great video, couple of suggestions. So thanks John for your comment. So he says that how to decide among REST, RPC and GraphQL, what are the difference between them? So for now, we have seen the basics of REST. We haven't gone to RPC and GraphQL, but I'm going to give you some idea about RPC and GraphQL as a part of your question. Apart from request response mechanism, could you also discuss about long polling, server-side events and WebSockets? So yeah, we are going to talk about these 2 points. Very nice question, John. I'm going to address both of them at a very high level. Later, we'll have dedicated video for RPC, GraphQL, long polling, server-side event, WebSockets. We'll do hands-on code as well. But for now, let me touch upon your question, how to decide among REST, RPC and GraphQL. So let's take a very naive example over here. Let's call a API endpoint over here. Let's say ABC, just a dummy one. And this gives me a lot of data back. I have certain clients who call this function, right? I call a service which has an endpoint. So this is my service over here, which has this endpoint, and it is called by several clients, right? Client A, client B, client C. Everybody calls this and we get the same response for the same value. So let's say this is not ABC. So let me just make it relevant for you. So let's say this is my book endpoint. So I want the information for the book ID 1, and this was a GET request, right? That's what we had, right? And we get certain fields. We get, say, 45 fields. There are 45 fields in total, right? Out of this 45 fields, only 10 field is required by A, maybe 12 fields is required by B. There could be an overlap, I don't care. 20 fields is required by C, and let's say 42 fields is required by D. Okay, so each of this response, let's say, is around 2 MB in size. Pretty heavy response, right? Now you see that this guy over here, this guy A, he is not using almost 35 fields, right? Even this guy is not using most of the fields. So these are the number of fields that's not used, right? And no matter what, I am sending him a 45 field response, which is 2 MB in size. So when a lot of call happens, let's say 2 million calls happen every 1 hour, and I send 2 MB, so 2 million into 2 MB of response I am transferring over the wire. But I see that most of it is not getting used, right, in most of the cases. So they don't need all this data, right? And to get this data, let's say this is our book service, right? For us, it was straightforward. We were querying and we are getting the data, right? But in real life, what would happen is this is making call to some other service. Let's say service X is calling service Y. Maybe service X is giving me these 2 fields, service Y is giving me these 2 fields, and service Y also making a call to service Z to get some of its data. He might not have all the data. So let's say this field is coming from Z, right? So all this operation, that this call is happening over here, this call is happening over here, this call is happening over here. So they take some time, right? It is all bound to some time, and it's also making some DB connections and getting the data. This is also making a DB connection to get the data, right? And most of the time we see that we don't need this data, right? So this becomes one limitation for your REST APIs. So in order to make it better, what we did was we came up with GraphQL. So over here, the server is the master who determines what would be my response, right? This is normal REST. But in GraphQL, what we can do is we can tell what we want. So it is a querying kind of, it's a API querying kind of language wherein I tell my API, okay, I am calling this method, but this is the response structure that I want. Maybe I want field 1 and field 5. So this guy over here, it says that give me field 1 and field 5 only. This guy over here, he says that give me field 1 through field 10 and then field 15 through 45. It might happen that for B, I don't need to make this call even to get him the response that he is looking for. Those 12 fields that he is looking for doesn't need to make this call. So I can simply skip that part, right? So what happens is your response now is no more fixed, right? It is a flexible response, right? So now what A gets is a response which is maybe 100 KB in size. He gets a response which is 120 KB in size. C gets a response which is, let's say, 200 KB in size. And D gets a response that is maybe 1.9 MB in size. So you can understand, previously we were taking 2 MB for each of the requests, no matter if they're using or they're not using, we are sending back the same response. But now with GraphQL, what happens is we can control how I want the response to be. The important thing to notice here is that the client application can only query exactly what it needs, right? Without relying on the server who was bluntly sending me a fixed response in case of REST, right? That's where we see a big improvement, right? So this was no more driven by server, but this was driven by the client. The client decides what he wants. There are a lot of other things also. We are going to talk in details when we go into GraphQL. So for now, I'm just trying to answer your question. And coming to the RPC, RPC is something very different. RPC is a remote procedure call. There are no standards for RPC yet. So what happens is when I call the server, so let's say this is my server. So we should have a RPC runtime. And then we need to do some stubbing, and from the stub we call the actual method of the function, right? It's a remote procedure call, so we are calling a method or a function directly. So this approach is pretty fast compared to the other techniques. So there is an additional cost in case of a remote RPC calls, because it's going to be a blocking call. So when we are making a RPC call, it is going to block your request until the response is returned back. Basically, it bypasses through many of the layers, and that's where we gain a lot of improvement on the performance. So we are going to talk about RPC in more details. We are going to do a hands-on and try to understand how to implement RPC. Next, you asked me about long polling, server-side event, and WebSockets. These are pretty big things, so I'll just touch upon them. So let's understand what is polling. Let's say I have a client UI over here. And I need to show a message that you have new messages or something like that, the way we see in, let's say, LinkedIn. And we have the server at the back. So what we can do is we can continuously make calls to the server. And it says, I don't have an update for you. I don't have an update for you, right? I make this call every 5 seconds apart, and the server says that, okay, I don't have an update for you. And when it does, it says that, okay, here is your update, you have an update, you show it, right? Continuously doing such call is called polling. And what is long polling then? Long polling is a mechanism that we have this UI and we call the server. This is my server, and we tell the server, okay, I have sent you a request. Send me the response back when you have an update for me. So this call is not going to end, right? So we know in HTTP, the connection is initiated by the client, right? The server cannot call the client. Client calls the server, and the server sends the response to the client. So you send a request, you get a response. So this request that is sent by the UI is kept open, and the response is not sent back until there is an update that I can send back. Or I can have a timeout. Let's say after 30 seconds, I say that, okay, let's send, I don't have a update for you. You send me another request. I will wait for 30 seconds. So here it's happening instantly, right? It's polling. And long polling is where I am not returning immediately, but I am holding to your request to see if there is any response coming in the duration that we have configured, right? It can be a configurable duration. The alternate to this approach could be your WebSockets or your server-side events. So WebSocket and your server-side events are both capable of pushing data to the browser. In WebSocket, what happens is you have this UI and you have your server. So you create a pipeline between them, and what happens is your UI can send data and your server can also send data whenever they want. So we have seen this kind of things in development of games or chatting applications. So wherein we can see a lot of usage of WebSockets. Now coming to the server side event, it differs a little bit from your WebSockets. So in the server side event, what happens is this is your UI and this is your server once again. So again, this UI establish a connection with your server, and what happens is your server can only push data. Your client can't. So the client establishes the connection and your server pushes the data back to your UI. And we have seen examples in share trading or stock market. I don't need to depend upon the client. I will just send my updates from my side back to the client. Another could be your feeds. We have seen Facebook feeds, Twitter feeds, LinkedIn feeds. So we don't need to wait for the UI to send me anything, right? I can just send the new feeds that's coming in. I can just send the data. And also we see these days that you get these browser notifications, right? So we can use server-side events in these cases as well. So these are the difference at a very high level, John. So I hope I was able to make some sense. But for each of the topic that you have brought up over here, I am going to create a separate video and I am going to cover in lot more details. Even for the rest, we are going to do it very soon. So with that, let's begin our episode 3, and we are going to understand how we are going to do the load balancing on our application. So before we do the load balancing in the application, we had some modules, right? So let me put them down over here once again. And let's say our application has grown to an extent of 15,000 requests per minute. So we wanted to do some analysis on the kind of requests that we are getting. So previously we have integrated with mybooks.com and we had more clients that are integrated with us. So all of them, ABC Books, World Books, My Books, is publishing into my site. So they are calling my API books and I am selling through them. So a lot of requests is coming up over here, what we have seen. When we did an analysis, we found that almost 10,000 of the request is only coming for my books module. They have a search capability on their site as well, and they are also calling my endpoint, which is API/search, in order to search for books. So I saw that I have another 2K request over here. So most of my requests, 12K request, is being served by these two services. Let's say cart has about 2K per minute and billing has about 1K per minute. But if we look at our module that we have distributed over here, so if I wanted to scale furthermore, I'll be taking this and creating another replica of it. So that's not going to help us. We need to go to the distributed system now. So all of these modules that we had over here is sitting inside a single jar. So now the time has come that we split them up into their own jars. So all of them goes to different jars. So how would our diagram look in this case? So let's go ahead and let's make modification to the diagram. So let's say this has become a jar which contains only the search functionality, right? So let me remove all of them and let me create them all. So I have all the services, search, cart, billings and books running in separate server, right? And what we have seen is that books is having a lot of load. So we wanted to scale the book, right? So I've taken the book service and created 4 instances of it, wherein my search and my cart may have only 2 instances. I don't need 4 instances for them. So let's say this is how it looks. So I have 2 instances for my search, 4 instances for my books because it's used heavily as we have seen over here, one instance for your cart, one instance for your billing, though it's not recommended that you have one instance, because if this goes down, everything goes down. But just for the sake of simplicity, let's say we have this, right? And we saw that there is a huge amount of load coming in for this, right? So if we need to scale further, we can only scale this part. We can bring in more servers over here. We don't need to scale the unnecessary parts as well, because we saw that there is not much traffic over here. So we are scaling them with our previous approach, right? Because there is only a single jar or a single deployment, and the server has to be replicated. So with this, what we have done is we have done distribution, right? So all the book related information will come and sit in your database, which is your book database. So you'll have a database only specific to your books. It's not being shared by the other services. So no matter which of the book service is getting called among them, this database with the books is going to get called, right? What happens is when you publish a book, you send a copy to your search module, which will have its own Elasticsearch, and these guys will not call my book service, but it will communicate with their own Elasticsearch over here. Similarly, the cart and the database, if they need something to be stored, they will have their own independent databases, and they are not going to share any database with other services. So that means now they are pretty much independent, right? And we also talked about storing files. So for managing the files, we can have a completely separate file server whom everybody is talking to, which is independent, which is not a part of these services. So we are clearly defining a service boundary over here. Previously, we have said that we have books.com and we have multiple IPs to have a lookup. But what happens generally is when you do a lookup with this domain name, you get a list of IPs, and your browser tries to contact the first one. If it fails, it goes to the second one. So the load balancing also does not happen. That was just for the simplicity of understanding. I explained it to you. So we have all the services, and also we have a file system. This file server will be accessed by most of them. We can create a service in front of it so that we can cache or get things done. We are going to take a look at that later. So for my cart and billing, I might not need to call the file server, but for books and other work, what we can do is we can use the file server directly. So when a book post is created, when we need to store the image, in that case, we can just go ahead and use the file server. So for search, we don't need to call this file server. The file path will be stored over here. I don't need to physically access the file, right? For the cart and for the billing, what will happen is we don't need to access them. But for the book module, we might need to, right? So that's what we did, but still it is segregated. Tomorrow, if I need to change this, I can simply decouple this and put a new system in place. Now let's talk about the load balancing. So we have these instances of my books module over here. So the load balancer could be of various types. We are going to talk about the application load balancer. There is a network load balancer also, but we are not going to talk about the network load balancer, but we are going to talk about the application load balancer. We'll have an application load balancer. So this is my load balancer. And this load balancer is responsible for sending the request to my servers. So it will look something like this. So you can see that this load balancer is distributing the load among these 5 instances of books. This is more like distributing a card. You can consider the load balancer as a card dealer, and he gives the first request to him, the second to him, third to him, fourth to him, fifth to him. And it will start over again. When the 6th request comes to the load balancer, it will be passing on to him. And this will go on in an infinite loop. Similarly, we can configure the load balancer for these services as well. So it will look something like this as you see in the diagram. So what we'll be doing is we'll be having different configuration for the load balancer. If the request is for the books, it's going to distribute the load in this servers. If it is for search, then to this 2 server. If it is for cart, then it will go to this server, and I missed for the billing. So if it is for billing, it is going to the billing server. We have to put different config. We have to put 4 config, one for cart, billing, search, and books. So what we can do is we can create a new domain, right? So we already have books.com. and we can create another one, a subdomain, and map it to the load balancer called api.books.com. So our domain mapping will look like this. So when you hit api.books.com, the request will land over here. But when you do a books.com, we are going to send it to a completely different server where we are going to have our pages. So let's say this is my web server where I have the HTML pages, all the pages. For now, we have just 5 pages. It's hosted in a different server. And when you type books.com, it goes to this server. And when you try to use the backend, you go to api.books.com. So essentially what will happen is this server over here will call books.com. So it will hit the DNS over here and he will be rerouted because it is api.books.com and he will be redirected to the load balancer. Similarly, we can get in our clients here as well. We have more clients, so let's get them. So similarly, my books, world books and ABC books will also end up calling this load balancer over here using the DNS. I'm not putting the DNS over here, but you can understand that it will all come through the DNS because the DNS need to be resolved first, right? So all the requests will be landed over here. So let me just change this. So let's not put the DNS, but it will be there definitely. But just for the sake of simplicity, I'm putting a direct arrow. So it will look like this. So when you type books.com on your browser, it opens this. And when books.com tries to add a book, view a book, it all goes to api.books.com, which goes to this load balancer, and this load balancer by default will do a round robin between the books instances over here and it's going to serve your request. So we'll be having this 4 APIs. So as discussed previously, my books, world books, ABC books and books.com all are treated as a client to my api.books and they all will have a API key, let's say. So all of them have a different API key as you see in the diagram, and using which I can segregate that what I should allow. When the API key is my books, world books, ABC books, they are not going to have access to cart or billing service, right? Because that is internal to my site. So I can easily control, right? And another thing to notice over here is that now my service does not know how many instances running behind it, right? All what they know is this guy. They don't know anything at the back. The load balancer acts as a reverse proxy, so you don't know what is getting called. Everything is a black box to the clients. What they know is the load balancer. They don't need to remember all these IPs, right? It has a very cleaner separation of concern over here, right? Now, a load balancer can do a lot of other things as well. This is one thing that we have talked about, a simple scenario, right? So here we have talked about the scheduling algorithm, which is called round robin. Also, one thing to notice over here is that this load balancer acts as a gateway to all my service. So everything happens through this entry point. You don't have a way to directly call him or him or him or anybody, right? So everything is behind this load balancer. You cannot skip this load balancer. So this load balancer acts as a kind of gateway as well for me. So what I can do now is I can validate your API key over here. I can check for your authentication over here, right? So I don't need to check your authentication in this services. So this guy over here knows that he's going to allow your request forward or he's going to send back the response from here directly, right? So we have talked about a scenario wherein my books was serving 10K of request, right? Now what happens is this request goes down for some time. Maybe it came down to 4K. So what can a load balancer do over here? So he knows that per container, he is going to allow 2K per minute. That's how we have 5 containers over here. 1, 2, 3, 4 and 5. Now, since the load is down to 2K, he knows that he can take off 3 instances, right? He can remove these 3 instances. So what he can do is he can take this, this and this down. And still your application works as expected. Now let's say your load starts rising after some time, it reaches 6K. So what it is going to do is it is going to spin this instance again. And if it increases, it will spin another instance. So you can have the 6th, 7th, 8th instance as well spinned up by the load balancer based on the demand in your service. What else? Load balancer knows all of these guys, right? He knows each and every service that is running, right? So what I can do is I can check the health, right? So I have created some endpoints over here, if you remember. So for my books, we had a few APIs, right? So we had the book API with the ID, and it was for get, put, and del or delete, right? And we had another one which was just book, right? So these are my API endpoint, which was a post endpoint, and I can create a health endpoint, let's say. So this just monitors and sends a 200 OK, saying that this is fine. This instance is fine. Load balancer over here can send a request to the server every 2 minutes at their health endpoint and ask them, are you healthy? So let's say all of them said, okay, 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 okay. So you're getting a fine response from everybody. And when suddenly the load balancer called this and it got a 500, say. So something is wrong, something is not working correctly, right? So he knows that this instance over here is unhealthy and he will not forward any request to this guy anymore. He will cut this off. He will spin a new instance of this guy and remove this instance completely. So he is capable of doing a lot of things, right? When you get a request, what it can do is it can do a compression of the request to save on the bandwidth. That is another thing that it is capable of. Also, what it can do is it can rate limit, right? So let's say I am exposing my search capability, but I wanted to put a cap, right? Based on the money I have received from the other guys. So I have no cap for me, but I have a cap for them. This guy can call my search maybe 2000 times per minute. He can call 1000 times per minute, and he can call, let's say, 500 times per minute. So my load balancer can keep a count and he can deny the request if it exceeds this threshold. What else it can do? So we have talked about few of them. So let me put them over here, whatever we have seen so far. So these are four as of now: workload distribution, auto scaling, health check, rate limiting. So let's see what else it can do. It can do authentication that we have already talked about, but I have not mentioned over here. So let me put that. So he is the one who distributes the request, right? So another thing that he can perform is request tracing. We are going to see request tracing in a lot more detail. So I wanted to track the request where it is going, right? So I have the load balancer, let's say over here, and this load balancer is sending the request to somewhere and he's calling something. From here we have been calling other things as well. So there is a complicated path that the request can go through. These are all your services, different services, right? It can help us to do this kind of tracing as well. And definitely this is the entry point, so he can act as a firewall to protect against all the malicious kind of API keys or the request that's coming in. It can stop it right there. And another important thing that I'm going to talk over here. So if you remember, I have api.books.com, this domain, and we have this books, and I'm going to get the book by ID, right? So let's say I wanted to see the book number 243, right? And this 243 books is being requested by this guy. I have also done. It's continuously being checked. It's a very popular book, so it is sending me 10K request per day. Maybe it's sending me 5K requests per day. It's sending me 2K requests per day. This is sending me some 15K requests per day with the same ID. Let's say this is a very trending and a popular book, right? Everybody wants this information. So what we can do in this case is we can put a cache in the load balancer as well. So what the load balancer can do is it can cache the response before sending it back. So next time when I get a request with the same book ID, I will not go to my servers. I'll just see if it is there in my cache or not, and I will be serving directly from my cache. This will keep my servers unoccupied with any request, so it will unnecessarily go and query the database. I don't need to do that, right? I know the response hasn't changed. if an update request come for the same book over here, I can go and invalidate that record in the cache, right? But when I know no requests came in for an update of the book number 243, so I am going to serve it from the cache. When I get an update request, I can just go and invalidate the entry. So definitely caching is a big benefit that we can get out of the load balancer. The scheduling algorithm that we have talked over here is round robin. So it is going to distribute the load evenly between the servers, right? But we can have several different strategies. One is like weighted round robin. So let's say I know one of the system that I have, for some reason it is 64 GB. It has a lot of RAM over here and has a better CPU as well. So I can put a weightage on this server over here. I'm going to show you the NGINX config, that how we do this. And also I'm going to show you for the other services, how do we configure. So single load balancer can route traffics to multiple services. This could be one thing wherein I can put a weightage if I have any requirement as such. So let me revert the changes. Let's go back to i3. And the other thing that we can do is we can do a least connection. So I can maintain a count that how many requests are being served by this books API or any API. So let's say my current stats, as I know, is 20, 27, 31, 85, 12. So when a request comes, I am going to send it to this guy and increase the count to 13. The next request that I get, I'll send it to this guy and update the count to 21, right? So I know that this machine over here is having the least number of connection, and definitely when I'm going to send the response back, I'm going to decrease the count again. So I can have a least connection. So routing the current request to the server that currently has a least active session could be another strategy. And definitely you can put a weightage again on this. There are many strategies. I am just highlighting few of the important ones, and once you have the concept, you can go ahead and read about it. And another strategy over here is when I'm sending a request to this guy and getting a response, I am noting down how much time it is taking. So when I sent him, it is averaging to be 12 milliseconds. This is taking 10 milliseconds. This is taking say 8 milliseconds. This is taking some 50 milliseconds. And this is taking some 100 milliseconds. So I know that these two guys are slow guys. These are quite fast guys over here. So when I get a request, this server over here, because he's doing at 8 milliseconds, maybe its time changes with that to 9 milliseconds. Still I'll send to him until he is the least one. I'll keep doing so, right? This could be another strategy. This is called your response time. So routing to the server that is responding the fastest recently. So I can maintain a window for the last 30 minutes or 45 minutes and check what's the average time they are taking in order to serve a response, right? And now it's not important that you will have only one load balancer. So let's understand the scenario over here. So we did an analysis and we found that we have 10K requests per minute coming in, right? So this was our number. So when we dig deep into this 10K request, we found, let's say 6K of the request is coming from India. Of course, I am global now. So I found that other 4K request is coming from Europe, different regions of Europe. So let's not call it India. Let's say it's Asia, right? So let's say currently I have all the servers over here in India, right? So what will happen is the Europe will have a high response time because of the additional hops, right? So you're doing a network call. Your call is going from Europe to all the way to India. So it will have some consequences for that, right? So let's go ahead and update this diagram to show what improvement we can do. So I have disconnected it from the load balancer and we are going to redesign this part. And we know that we need 3 machines for India to serve 6K request in Asia, and we need 2 servers in Europe, which is going to serve another 4K request for the Europe region. So I've created 2 clusters, one for Asia having 3 servers and one for EU having 2 servers. And what I can do is I can put a load balancer here as well. So these load balancers over here is going to send the traffic to the respective servers, right? So this is in the Asia, this load balancer is in the geographic boundary or it's inside Europe. So this is going to do a round robin of the request in these three, and this is going to do a round robin in these two. This load balancer is now going to send the traffic to Europe or Asia. So the load balancer is capable of sending the request based on your region as well, and it can send the traffic to a particular region. So it can be region aware, and when it sees that the traffic is coming from Europe, it will send over here to this load balancer. He is going to do a round robin, and if it sees that the request is coming from India or Asia, it's going to send the request to this load balancer who's going to do a round robin over here, or whatever policy that you choose. There is another concept over here that's a interesting one. Let's try to understand that let's say this is my IP address and I want my request to go to a particular machine all the time, right? So whenever a request comes to the load balancer from this IP, it is going to use the hash of this IP, and using the hash it is going to send the request to a particular server, right? And next time when I get a request from this IP address, so the hash is common, right? The hash function that we are going to use is going to remain the same, so we'll get the same hash value and my request will keep going to this machine only. So this technique over here, in order to send a request to a particular server as long as it is available, is called a IP hashing. So we can have this another scheduling algorithm over here which is called IP hashing. This IP hashing will work on the IP address of the incoming request. And definitely when it's the entry point for all your requests or network calls, you can do a monitoring and logging as well on all these incoming requests. So with that, I have added 10 points over here. There are more. We are going to see more when we do a hands-on. And as I promised that I'm going to show you the NGINX config. So let me open the NGINX config and show it to you guys. So here I am at the NGINX site over here, NGINX docs. So you can see all the configs over here. So here is your config. So over here you have the server configuration under HTTP. So over here you specify if the location is /1 or /2. So for us it will be book, search, and all of them. And if it matches this rule over here, this configuration will apply. And how does the configuration looks like? So let's go ahead and take a look at the configuration. So let's take a look at the full configuration over here. This is the Nginx configuration file for you, which is named as nginx-conf. So to look at few of the important things over here, as we discussed, we have a ability to log things. So here is what we are logging. This is what our log format looks like. So we have the remote address, user, the time, local time, the status, the request body, the byte sent, the referrer, the agent, and all those things. So here is the first config that if you have domain1.com or www.domain1.com, you'll be redirected to this URL. If you have domain2.com, something like this, or www.domain2.com, you'll be redirected to this. And also to notice over here that this will be redirected in case if it has all this as your types. So the static file types, as you see over here, it will be redirected, and it has a expiration as well. For any other request with /, it's going to redirect it over here. Then we have configured something as an upstream. This upstream has a name which is big_server.com, and it has 4 server listed over here. 2 of them has a wait. We talked about weighted round robin, so you can see that we have specified the weight, and 2 of them are normal ones. So this will be used in some of the server config. So let's take a look. So if you see over here, you have this bigserver.com. So if your server name contains bigserver.com, so you will be redirected to bigserver.com. So this name and this name, if you see, they are matching. So this rule will be applied in the location part. So it will be a round robin algorithm on this, but a weighted round robin. So this is a config how it looks. Now let's take a look at how do we apply different other algorithms that we have for load distribution in our Nginx config. So back to this document over here. So you can see that there are some configuration. So we have already seen this upstream configuration. So we have a weighted and we have a normal and we have a backup also over here. So you can see over here in your upstream, when you don't specify anything, it does a round robin. That's the default behavior. And if you want to use the other methods, you can use a least connection, you can use a IP hash. So you have to just provide the algorithm that you wanted to use. So over here, you can see that they are doing a hash on the request URI. You can read the details over this documents. I will share all these documents over here. So in my playlist for system design where we did hands-on, here we have done Nginx as well on the episode 19 as you see over here. So understanding and configuring Nginx to load balance Spring Boot application. So if you want, you can go ahead and check out this video wherein we have done a hands-on over here completely. So I have configured the Nginx myself in this video. So do go ahead and check this video. This is going to be a relevant video at this moment for you since we have done the basics of load balance. So you're going to enjoy this video wherein we have configured our own configuration and we have seen that how this request is going to the different machines as you see on the screen over here. So click on the card, do check out this video, and on the next episode, we are going to explore more areas from distributed system. So with that, I'll end this video over here. Do let me know your thoughts on the video. Once again, please do comment. And if you have any question, put them in the comment section. We are going to discuss as a part of the next video, just as we did in this video itself. So thanks once again for watching the video and see you soon again. Bye bye and take care.